Hi everyone, welcome to IQ Space. Today we are represent the Nalaiyathiran project of Smart Waste Management System for Metropolitan Cities. The contribution of this project, myself P. Dharshan and Mr. KARTHIK, Mr. THIYAGARAJAN and Mr. NITHEESHWAR. The Smart Waste Management System is an IoT-based garbage monitoring system. It is used for maintaining the clean environment of the cities. The Smart Waste Management System is worked under 24/7 hours of time simultaneously. It also provides the segregation process inside the bin using deep learning algorithm. The Smart Waste Monitoring System is an efficient system for new IoT technologies. And the proposed solution of this project, problem statements. The problem statements are giving the accuracy in garbage monitoring, and the idea solution description. The innovative idea of this project is we'll use the segregation process, and novelty and uniqueness. We are using IBM cloud for creating an efficient monitoring system, and the social impact of our project is very efficient monitoring system and accuracy, and business model is our revenue model and scalability of the solutions. And modules, we are using two modules, IoT environment and segregation. IoT environment consists of control the garbage bin using ultrasonic sensors, GSM, Raspberry Pi, and after segregation the IoT environment provides its implementation. And the technical architecture consists of the components of IoT device, Python code, IBM Watson, Node-RED, Web UI and user. And this is our Nalaiyathiran dashboard. In the dashboard, our team members collaborate with me and we have completed the project successfully. And 94% of work will be given to me, and we have submitted the 94% of work. And now we are see the Git repo. Git repo we are using to store our works, and in this Git repo contains our project tasks and modules. And next, the software requirement of Smart Waste Management System is Python idle. We are using Python programming language for software requirement. And system requirement, 4 GB RAM, we wanted to work it out, and garbage level detection in bins, getting the weight of the garbage in the bin, allows the authorization person to empty the bin whenever the bin are full. Garbage level of the bins can be monitored through a web app, as well as we are using the mobile application for monitoring the garbage bin level. And we can view the location of every bin in the web application by sending GPS location from the devices. Next, we have moved to the Python source code. The Python source code manually import the repositories like time, SYS and random numbers. And we are getting the authentication token, authentication method, device type in IBM Watson. And we are using the principle of if the bin will be 90% full, the intimation will be come to the bin is full, else the bin is not full. And we are using the try and accept. And we are using two methods. One is connection, like device connection, and another one is device disconnections. This device connection give the notifying, callback, and IBM Watson methods. Finally, the device will be disconnected. And this is our Python code, respective output. And in this output, it represents the two parameters. First one is bin level, and second one is the bin notification. And the bin level randomly give the percentage between 1 to 100, and the bin level notification give the two parameters. One, the bin level is full, and the another one is the bin level is not full. In the scenario, we are using conditional statements. 1 to 90, the bin notify the bin is not full, and 91 to 100, the bin will be notify the bin is full. So it will be generated by our manual work. And next, we are moved to watching the IBM Watson IoT platform. In IoT Watson platform, we are creating an device, and the device contains his ID and device type and data, and added location and connection status. And recent events will give the simulation details of our IoT Watson device. And now we are clearly see the simulation process in our bin. The IBM Watson gives the bin status simultaneously in every seconds. IBM Watson will work under the Python code. Whenever the Python code what is still, the IBM Watson will give the respective devices. And the IBM Watson device nodes will be given to the Node-RED. Node-RED is an application to create a device database, and also create a data sets in dashboards. Both IBM Watson and Node-RED are very easy tool to create a website and implement the Python code. Since we are seeing the backend operations like IBM Watson, Node-RED, and Python simulation, and now we are seeing about the results, outputs. A wonderful outputs will be given to our MIT App Inventor. We are creating an mobile application. The Node-RED and IBM Watson data will be given to the IBM MIT App Inventor application. It will give the monitoring system of our bins and give the notification to driver to collect the garbages, and it will be gives a smart short route path for driver. First, in this application will contains the three major parts: one admin page and user page and driver page. The admin page contains the databases of creating and driver, view complaints of user complaints, and finally it will contain the report work. And next contains is the user complaints, and finally truck driver page. The truck driver page will contains the properties of two properties like bin level and view map. The bin level gives the information to the driver where he go to and collect the garbage, and truck driver move to map section and search for which area I will go, and finally he or she will get the short route path, and all the data will be collected in wireframe database.